Okay, sir.
Welcome to Grammar Science AS levels, and we are going to start our chapter number 4 topic assembly languages, a very important topic of our chapter number 4. As we know, computer is a machine which is going to be understand a language of binary, zeros and ones. But there
Yes,
is
sir.
a language called assembly language, which is a part of a binary language. As I told you that assembly language is a part of binary language because this is a language in which we use numeric codes. Numeric code means we are using the code in a form of English alphabets. So the computer is able to understand that codes and finds it easy to store into the memory. That language is called assembly language. So writing program in machine code is a specialized task. We all know that writing a program in ones and zeros, it's difficult. So the programmer invent a language which is in a human readable form. In that language is called assembly language. So the first programming language to be developed was assembly language. And this is closely related to the machine code and uses mnemonics instead of binary. So the computer
Okay.
is not going to use, or computer program is not going to use this binary. They use some mnemonic codes, and that mnemonic codes is called assembly language. So if I write LDA, in English, it means first. If I
Okay,
write
sir.
A double D, in English, it means second. And STO means sum. So if I'm going to write an instruction like this, look, sum assigns LDA A double D. What does it mean? You can say,
Uh,
oh, one mistake. STO, yes, STO. So you can easily understand this language. How?
oh,
Because you have a meanings here. So if you are going to read the meaning, can you understand what it is written?
yes, yes.
Tell me.
Sum equals to first plus second
Perfect answer. Sum assigns first plus
plus
second.
second.
So in this way, the user is able to understand the instruction. Look, it's very easy. Even you are the beginner. You get the base. Why? Because you know the codes, you know the code meanings. So in this way, the assembly language works. And in this way, the assembly language provides you a very easy platform to make a program in an English language so the computer and human both are feeling comfortable in it. Got it?
Yeah, okay.
So there is one more example you can see. The first programming language to be developed was assembly language. So we know that it uses mnemonics. So what does it mean? Look, L double D total, A double D 20. So what is L double D? L double D means first. So first you're finding the total. On a second, you're going to use 20. And in STO means sum. In sum, you're going to find out the total. So this helps humans to understand the program. But if you're going to use this thing, it is difficult. And even if you're going to use binary codes, it is almost ununderstandable by humans. What do you think?
Yes, sir.
Isn't it? So
Yes.
assembly languages providing us a forum for the programming. So the users and the machines are both happy in this. So the structure, let's discuss. Did you notice that red and green color is using here in writing the code in assembly language?
Yes.
Red and green, yes. So the structure of assembly language and machine code instructions is the same. Yes, we know that each instruction has an OP code that identifies the operation, right?
Okay, sir.
Most instructions also have an operand that identifies the data to be used by the OP code. So if I'm writing 2 plus 2 is equals to 4, this is my arithmetic operation. So in
Okay,
this
sir.
instruction, we have two things, OP code and operand. What is OP code? Look, OP code identifies an operation to be carried out. What operation is going to be happened here in this instruction? What you are performing?
Addition.
Addition. So addition will be the OP code.
Okay, sir.
And what are the operands?
Operands,
two.
2 and 2.
Exactly, they both are the operands. So I just give you an example of a normal arithmetic operation. In assembly language, we have OP codes and operands, but they are a bit different. Is that okay?
Okay.
Let's see how. Look. L double D. What is the meaning of L double D up there?
LDD is total.
Yes, it's total. So look, you're totaling, it means you're going to do addition of something. So indirectly, you're doing addition, totaling. And what you're
Okay.
actually, what you're working on a total, that is operand.
Yes. Fine. Okay.
So if you're
Understood.
writing it in machine code, you can see OP code is 0, 1, and operand is 40. So it's almost ununderstandable. But I'm just giving you an example like that. Okay.
Okay.
Great. Okay, so what we have to do first, you need to write down about assembly language in a very short way. You need to write down on 2 or 3 points. You need to write down this
Okay.
example, and then you have to connect this example with it. Once you're done, you need to write down these codes. Only this part.
Okay, sir.
And of course, you need to write down OP and operand. So you need to write down everything in a short and precise, okay?
Okay, sir.
Okay, great. So
Yes,
while
sir.
we're going to write a program, so program written in an assembly language is called source code. And once the program is executed, it's called object code. Remember this thing, while you're writing the program is called source code.
Source code. Okay, sir.
Source code. And once you're done with the program and you are going to compile it or test it or run it, it will become object code. These are the two words, two terms you have to remember, okay? Object code. So while
Okay.
we're going to write a source code, we need to translate or interpret our program. But if you're writing an assembly language source code, so our program will be interpreted by an assembler. Remember, we have 3 types of translators: interpreter, compiler, and assembler. So the program which is written on assembly language is being translated with the help of assembler.
Okay, sir.
Assembler is a translator which converts our assembly code into machine language. And
Okay,
if you're
sir.
writing a program on Python, it means it is a high-level language. So the program we written on Python is translated with the help of interpreter or compiler. But while we are talking about the assembly language is interpreted with the help of a translator called assembler.
Okay, sir.
So there are 2 types of assemblers. Now, assembler is a translator. There are 2 types of this translator: single pass assembler and 2-pass assembler. Yes.
Okay.
What is assembler? Assembler is a translator.
Translator
Which
and the single
converts
pass assembler.
assembly code into machine code.
Okay, sir.
Then we have 2 types of assemblers: single pass assemblers and 2-pass.
2-pass.
Okay. A single pass assembler put the machine code instruction straight into a computer to be executed. So it's very easy. Single pass assembler is going to forward the code into the assembler for translation,
Okay,
right?
sir.
But a 2-pass assembler produces an object program in machine code. Okay, so the 2-pass assembler is not going to forward the code into the translator. No, first it converts the data, the program, into machine code, and then storing it, then loading it for the execution. So 2-pass assembler is a different thing. In a single pass assembler, it converts your machine code straight into a computer memory. Forward it straight into computer memory. But 2-pass assembler, first it converts the data into object code, then translate
Okay.
it, store it, and then execute it.
Okay, sir.
Okay, now assembly code language instructions. There are different types of assembly language instructions. Now, a very important topic is coming. Assembly language instructions have a lot of types, right? But before starting the types, I'm going to teach you a topic, addressing modes. Addressing modes. What are addressing modes? First, let me just give you an idea. Look, these all are the assembly language codes. These all are the assembly language,
Assembly language codes.
right? Okay. So before starting this, I'm going to teach you what do you mean by addressing modes. So assembly language and machine codes using different addressing modes, right?
Yes,
What
sir.
are the addressing mode? Listen. Number one, absolute addressing. The content of the memory location in the operand are used. First, the thing is, let me tell you, this is our memory. This is our memory. In our memory, our data is stored in a different locations like that. Every location have a particular address, just like you are living in a home and you have a street address. So if I'm going to ask you, what is your street address? You told me, sir, I live in blah, 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 right? Just like that, in a computer memory, all the data is resided on a particular address. So from that address, the instructions are taken. Are you getting it?
Yes, sir.
Okay. So in the absolute addressing, the contents of the memory location, contents means the data, like A is a data here, B is a data here, C is a data here, or blah, blah, blah. Okay. So the content of the memory location in the operands are used. So whatever the contents are stored in the memory location. So let me tell you, like 00 is a memory location, 10 is a memory location, 11 is a memory location. So if I'm going to ask you, what is the data you see on the memory location 00? So
Okay,
you
sir.
said, sir, I see A. And if I ask you what is the data resided in memory location 10, you say, sir, it's B. And if I ask you what is the data on the memory location 11, you said, sir, it's C, isn't it?
C. Fine. Yes.
Fine.
Okay.
So this is a kind, it is a work of absolute addressing. The content of the memory location in the operands are used. For example, if the memory location with address 200, so look, there is an address 200.
Okay, sir.
Contain the value 20. So it contains the value 20.
20.
So the assembly language instruction LDD 200 would store 20 in the accumulator. So if I'm going to write LDD 200, look, LDD 200. So what is resided in 200?
L double D.
Come on, man. What is resided in 200?
200.
Look, this is a 200 address. What is the data inside it?
20.
Yes. So the computer would load 20.
Okay.
Right into the memory or accumulator. Accumulator is a register. Remember?
Okay, sir.
Right? So
Yes, sir.
this is the address of the memory location, that is 200, and this is the data. Did you understand?
Yes, sir.
So if I'm going to load 200, what will be the load in the accumulator?
20.
The value of 20 will be loaded into the accumulator, because actually 200 is an address, and what is the data inside it? 20. So the 20
Okay,
will
sir.
be loaded in accumulator. Right? This is called absolute addressing. Right? In absolute address,
Yes, sir.
you have an address. In that address, you have a data. So if you are loading the address, it means you are loading the data inside it. Like, listen, you are living in a home. Your home have a postal address. And who is living inside it? You. So you are the data and your home address is your address. So if I'm going to call your postal address, definitely I'm calling you because you are living inside of it. So this type of addressing is called absolute addressing.
Okay, sir.
I don't think so you got it.
No, I got it.
Tell me.
So it's basically like if the memory location is like 200,
You can
they will
told me in
give.
Urdu. It's okay. You can told me in Urdu.
No. Like I prefer I speak in English.
ठीक है. Like sometimes what happened, students knows the thing and they are like not going to narrate it clearly. So if you feel comfortable in speaking in Urdu, you can do. I'm not going to bound you. The basic thing कि तुम्हें समझ में आए, चाहे language कोई भी हो, language is not a medium. तुम्हें
Okay,
सिर्फ
but
समझ
sir,
में आनी चाहिए
sir,
बात.
sir, 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 let's say if it, I'm just gonna, example, if the address was 100, will the LDD come out as the output as 10?
LDD, okay, fine. So the address is 100 and the data is 10
Yes.
inside it.
Yeah.
Perfectly.
No, would, that's fine, right?
Yeah.
I'm just
Okay,
trying to
what
get
is
the
direct
concept.
addressing? Look, direct addressing and absolute addressing both are same. Direct addressing and absolute addressing both are same.
Same,
You
okay.
can read it if you want.
The content of the memory location in the operand. Example is,
Look,
okay.
right? Okay, now, so I'm going to indirect addressing. What do you mean by indirect?
Wait, so
Indirect.
sir, absolute and direct addressing are the same?
Yes. Look in the last line, it's written.
Oh, yeah, okay, it's
Are
written, okay.
same. Look. I'm going to make a bold. Yeah.
Yeah,
Now,
okay, sir.
what do you mean by indirect addressing? Listen to me very carefully. The contents of the memory location in the operand are used. For example, if the memory location, yes, if the memory location with address 200 contain the value 20, okay, fine. So this is 200. Look, no, I'm writing here. This is 200. This is address. And what is the data inside it? Tell me.
20.
20. Okay. And the memory location with address 20 contain the value 5. Okay. There is one more address, 20. And in 20, what is the data? 5.
Okay.
So the assembly language LDI, look, LDI 200 would store 5 in the accumulator. So if I'm writing the code, assembly code LDI, it means indirect addressing. So LDI 200, look. So LDI
Okay, sir.
200 will take the value 200. What is the value in 200? 20. And what is the value
Okay.
in 20? 5.
5.
So it will directly call 5. Look.
Okay.
So this is an indirect addressing,
Fine, sir. Okay.
right? And this is like a box under a box. You have a box. In that box, there is one more box. So if you want, if I call a box, so you can take out the box which is under the big box. So it's just like a box under a box thing. Like you have a 200, that is your address. In 200, you have a value 20. And in a 20, you have a value 5. So if I want LDI 200, so it will directly call 5 because it is going to be indirect working like this.
Okay, sir.
Now write down absolute addressing and indirect addressing, or direct addressing, you can say.
Okay, sir.
Write an example as well.
Okay, sir.
Okay, now we are going
Okay.
to start the topic of indexed addressing. The contents of the memory location found by adding the contents of the index registers. So what is index register? What is memory location? You will find out all the answers in these things. You see, these are the assembly codes. These are the values on which you are going to move your question. And in the way, we have to do some questions of assembly codes. So in our assembly language, we have the registers. What? We have some registers, and these registers are going to store the data. So this is the name of registers, like index register, right? You write
Okay.
IR. IR is an index register. In index register, we store some values, right?
Okay, sir.
To the address of the memory location in the operands are used for. So we store some value here, and this value is going to be operand, used as an operand in our instruction. For example, listen, if IR contained the value 4, okay, so I'm writing 4 here, and the memory
Okay, sir.
location with 204 contained the value 70. Okay, look, there is a value 204. And
Okay, sir.
what is the value? 17 inside it. So the assembly language instruction LDX200 would store 17 in the accumulator. What does it mean? Listen, this is an address. What is the address? 204. And what is the value in IR? 4. So this will be subtracted like this. 204 subtracted
Okay.
4 becomes 200. So the value of 17, which is stored in 200, now stored in 17,
Okay.
like this. So this is how the index register is going to be subtracted from the address, which is having the value. So the 204 is the address having the value 17. So if we are using IR index register, it is going to subtract the value from 204, it becomes 200, and 17 automatically going to be stored in the register 200 or with the value 200. So the index addressing means you are using the index register. In index register, whatever the value is, which the value have to be subtracted from the address given. So the address is 204. So 4 is subtracted, becomes 200, and the 17 will automatically move into the accumulator 200. Now,
Okay, sir.
immediate addressing, the value of the operand only is used. For example, the assembly language instructions LDM. What is the value? LDM. This is for code.